Okay, welcome everyone. My name is Ankit, and today we will be talking about code migrations. Who doesn't love code migrations here? We have here with us Chris, who will also be joining us. And I would this is going to be a smaller group. We're going to have collaborative conversation. Let's try to make sure this is not a monologue, that everyone can participate. Feel free to raise your hand if you have any questions, or use chat to post any questions during the session. We do expect we're going to do initially some presentation to talk about some of the concepts and do a little bit of demo as well. Um, and thank you everyone for making time. We will also share this recording after the session. David, can you just confirm if the recording is going through? I think, okay, it is. I can see that. Okay,
Yes.
cool. All right. So let's start with a little bit of slides, and then we will get rolling from there. Okay. All right. So everyone is familiar with AI code migrations, and this is something we're going to be talking a little bit about. You may not be familiar with AI code migrations. You're at least familiar with AI tools today and the code migrations. So before that, let me introduce ourselves more formally. I'm Ankit, co-founder and CEO of Aviator. We are a company building developer productivity tools. Previously, I have led engineering in a few companies, including Google and a bunch of startups. Chris, please, can you also introduce yourself?
Yeah, so nice to meet everybody. Chris Westerhold. I kind of lead our global practice at ThoughtWorks around what we call kind of engineering excellence and whether that's injecting kind of AI into kind of developer workflows, platform engineering, developer experience, developer portals. Like I've spent a lot of time on this kind of next generation developer portal recently, and how do you really start to think about these things differently in the new modern kind of AI world.
Amazing. Okay, so let's talk about migrations, right? Code migrations are inevitable. You have to do various kind of migrations. It comes in different shapes of forms, languages, frameworks, deprecated APIs, security patches. Um, But the reality is a lot of migrations stall, right? And this is because of some challenges that the organization have, changing priorities, and this tech debt compounds. I'm sure, Chris, you have also seen a lot of like migrations, or like at least participated and talked to many engineering leaders where they had some failed attempts of migrations.
Well, absolutely. We just finished a major kind of migration right now from like Java 8 dependencies up to Java 21. And, not only can they be painful, they can just induce fear. It especially after it's gone a little while, where it's not, a React 17 to 18, it's 13 to 18 or something like that. It's a much larger span where there's a much bigger scope of change. And then you end up just falling further and further and further behind. And to kind of double down on the security problem, like with those older versions, you end up with more vulnerabilities, you end up with end of life problems. Then the cycle even compounds even more. And they're inevitable, but they definitely can be painful.
Okay. So I think why it's important to really understand, like, what are the challenges of migration? So there are several reasons why migrations fail. I think scale is definitely one of the things which is a very critical part. Many of you folks might be familiar with frameworks like Dependabot, who do upgrade of, security patches and like minor upgrades. Those things are easier, right? Even at a large organizations, those things can happen at a pretty comfortable level. But when we get into places where you, as Chris was saying, right, like Java 8 to Java 17 or whatever you're doing, some of those migrations can be massive. And those migrations become massive because you, again, have fallen far behind. And now, kind of like any changes you have to make require significant improvement. And there are like several other reasons like this, right? I think tribal knowledge is also one of the most complicated ones, especially in the organizations today. People move around a lot, right? Like they might leave the organization also, which means is now anybody who understands the nitty-gritties of why a particular library or a framework was used, that person may not be in the organization anymore. And everyone is worried that when you're doing a migration, like how do you actually like verify, test these changes? Because yes, you can just ask AI to do the entire migration, but like you still need a way to ensure that you didn't break anything. So there are like several reasons why migrations fail, and it's important to really like, understand and um, register those reasons. So obviously everyone is kind of like trying out different approaches. There are like some new frameworks that are coming up also, and we're obviously going to talk about one of our frameworks as well. But like the most classic way of doing it is just doing migrations manually, right? This is kind of like how we were doing it even 5 years ago, and today also many of the migrations actually still happen manually. Code mods have become still more popular, especially in some of the newer frameworks. I think React, Next.js, those kind of systems are actually building good mods, which makes it easier to you for you to do migrations. But again, like they're like here and there, it's not available everywhere. Sometimes you have to write your own code mods. And if you're kind of like doing regex, code mod kind of stuff, it's easy for them to fail. And I think building code mods from scratch can be very brittle, right? Like it's you are actually making certain changes based on your knowledge, but it may be only limited, right? Like you may not understand all the complications behind a migration. There have been some promises with the AI migration-based systems. There's also systems like Open Rewrite, which actually help with some of these migrations. The challenge with all of those things, again, is you need to still understand what are the limitations? What are kind of like the places where it might really fail? AI, especially, everyone is familiar with like hallucinations now. I think we are living in 2026. So there are, as much as AI provides opportunities for us to create better migration frameworks, it in itself can have its own limitations. Um, Chris, anything you
Oh,
might want to
I
share?
mean, from the AI perspective, there's only so big of a context window that you can truly start to understand. And if you're getting behind on kind of migrations, other bad patterns have probably come to the forefront. And um, as those issues start to compound, that context is even harder to get into kind of that one shot of, you just can't figure it out. One human probably can't figure it out. And there's a lot of risk that comes from that kind of one shot AI. And really all of these they all have different problems, but really they all come down to risk at the end. And that's why people tend to, they don't ignore them on purpose, but they just kind of shuffle them to the bottom of the priority list and hope that it goes away, because in this model there just isn't a good way to think about it.
Right. Which kind of like also goes to some of the scale things you were talking about, right? It's just every migration work can be massive, which always means is unless it is very properly prioritized in the organizations, they always get shoved down the stack. And that's also part of the reason why many of the migrations never finish.
Mhm.
So, what migrations actually really need? So, migrations need deep understanding of the code base. It needs consistent application of patterns across all instances, right? So, everyone uses libraries and frameworks in a very special way. And that's why having a standard way of doing migrations doesn't always apply for everyone. And this is kind of like why code mods type of systems sometimes fail. And it's important to kind of like really acknowledge that and understand kind of like, what those limits are. Handling edge cases, again, kind of like on the same issue, right? Everyone uses code base. Everyone's code base is slightly different. So you cannot apply migrations broadly. Um, but you need to also learn from human feedback. Like that's why we talked about like, this conversation is going to be about human in the loop for the AI. Like having that feedback from the humans is important. If somebody like selling you is like, hey, we're going to actually do the migration completely automatically, very likely, unless they have been working on that space or like that kind of a migration for a long time, very likely this is not going to be true. Even if they have all these systems in place, they will still need a human feedback. And that I think is like very critical for any migration framework.
Mhm. Agreed. And
Um, yeah,
it takes a lot of these things tied together, right? Like that deep understanding of the code base can't really be understated. because that's where, again, back to that kind of risk and fear, like, you know, you know, as we were kind of completing the one we did last week, like there was lots of naysayers of like, well, yeah, but like, what if this happens? Like, and how do you mitigate that risk? Like that's always the thing that you want to make sure that you really, kind of nail down through this.
Right. Okay, so one of the frameworks we're going to talk about today, or like the framework we're going to talk about today, is called Runbooks. This is a framework built by Aviator. Think of Runbooks as an executable specification that guides agents through a complex multi-step task. Now, there are like a few things which are important here, right? We're talking about specification. I don't know how many of you folks are familiar with spec-driven development, but spec-driven development essentially like offloads some of the complexity of the context window challenge that Chris was talking about, which is, okay, how much can an agent understand at any given time? With specification, you essentially like write down all these details into a document and then have agents use that document as the reference to process complex work. And multi-step is also important, right? If you think about a migration, like especially even taking the example that Chris was giving a migration from a Java 8 to, I don't know what was it 20 or was it 17?
21 is what we went to.
21, right. So
Yeah.
it's not something that you can actually do it in one shot. It's not something that you can really expect the entire code base to just migrate in one giant pull request. So really understanding that part is like, how do you actually like, do it in a step-by-step function, which helps you validate some of those hypotheses and also be able to start ironing out the corner cases and sort of like, the edge cases. So that's kind of like, one of the some of the core concepts that we built Runbooks on. So it actually creates, we will walk through the demo, so some of these things will start making more sense. But it does create a system where we define migration, and depending on the complexity of the work you're doing, it will break it down in specific steps. Now, these steps become something that you can go and read and even execute one by one to truly understand what changes are going through in those steps and be able to course correct in the places where it's going wrong. So think of this as essentially like you are becoming the orchestrator and uh, the actual code is executed by the AI. But here you're providing some of the guidance using these shareable specs. And one of the most important parts about our framework is it actually is a multiplayer concept, which means is a migration is not something that you can just do it in isolation by yourself. So this provides you with a way through which you can actually invite your entire team to work on the spec together. The beauty of that is now everyone can provide feedback on the specs and make sure they understand all the complexities which are going into the spec. This ensures like any kind of verification that you may have to do towards the end when the code is generated, you can actually shift left and do it even before the code is written. And this is one of the key learnings and the key insights which make migration work amazingly well, and they improve the accuracy because now you're essentially catching all these issues in the corner cases through the medium of spec instead of like trying to read through every line of code.
Well, and that I think the other, you're going to continue to have to do this, right? Like it, we're not stopping at Java 21, or we're just, things are going to keep progressing, and you're going to have to do this more and more and more. And so, how do you learn to be better? And, when I think about kind of just the general concept of the run book, it's, you know, yes, you can work your way through it step by step by step by step. But now you can now leverage these same run books to do it again in the future and again in the future. And you don't have to have such a high cognitive load for the actual engineer. And because one of the things we talked about, hey, you have to have really smart people. Yes, you do. But now instead of them having to focus on, man, I got to keep bumping my versions, they can continue to work on the business, like critical aspects of software development, and just focus less time on things that have kind of become more automatable, to make up a word.
Yeah, I think another way to think about this is actually next time when you have to do this similar migration, you're not starting from scratch. You're actually taking what was done last time, capturing all of those learnings and building on top of that. So that essentially means any kind of corner cases, any kind of edge cases that you identified for the first time becomes these building blocks, these learnings that actually, like I will also talk a little bit about that. But like these becomes like the building blocks, which actually help you create better frameworks for the future. And with Runbooks, you also get the ability to actually use your existing tools. So it integrates with Cloud Code, and essentially the coding agent itself uses the same framework that you are familiar with, and we essentially build these building blocks on top of it. So this is kind of like the part which I was talking about. One of the key things with Runbooks is it actually captures your learning and continuously keeps on improving, which means is like one time you provide certain feedback on what are some of the corner cases, what are some of the special ways and how you work. These become part of the system. These become part of the context, which now gets propagated to any subsequent work that the agents are doing. And this is also like one of the key aspects along with the specs, which make a system that is constantly improving. And on the specs itself, you can actually also publish them. So this is actually like in the demo also, we will show you migration, which will be done on a very small code base. The concept there is you always start with a small space or like a small place where you actually start the migration. And you can actually use that spec and share with others. That way you can actually have other people also use the same spec to do the migrations in their services in their code base. So this essentially creates a way where you actually reuse existing work that one person is doing potentially or a team is doing and share with the large organization. So in an essence, like we create a system that gets smarter with every task. So the way typically the system works is it starts with some of the research, it kind of like tries to understand your use case, then it generates a plan, which is the spec, and then you provide the feedback. It collects all of those feedbacks, captures all of those information in the learnings, and starts writing the code. And it's not even done when the code is done, right? Like it is going to look at all the review that you provide. It actually like work on your review feedback, as well as it also runs your CI agents. It runs the verification steps to ensure the quality. So essentially what we are creating is a feedback loop. And this feedback loop is very important to actually perform any kind of large code-based migrations. But I think the most important part of this is a framework which is capturing your tribal knowledge. So imagine now all of this knowledge which lives in people's mind. Now this gets documented. So think of this as like your living, breathing documents, which are evolving as your organization grows. Okay, so I think this concludes some of our presentations. So we will go into the demo. I guess we do have a slide. Okay, so this is the last slide. I'll kind of like just quickly talk about like, this is not something like this is something we've already covered. So with this framework, you get like consistency, scale, intelligence, provides a memory layer, and it provides visibility for the entire team. We'll share these slides as well, so don't worry about this. I want to be mindful of the time. So we are about like 20, 25 minutes in. So let's see if anybody has any questions. David, I don't know if you want to kind of like help drive anything if anyone has questions, or people can raise their hands and we will otherwise go into the demo.
Yeah, yeah, I think it could be pretty open-ended. I know we have people from different companies. I'd love to know, like, has any of this resonated? What AI coding challenges have you run into on your team, right? Like, how have you tried to solve for them? But yeah, we're lucky
Okay.
to have a group that anyone can kind of just speak up and share
Yes,
their experience.
Sayed, I see your raising hand. Go ahead.
Yeah, thank you. Like a lot of what you talked about resonates in terms of the challenge of migration upgrades and even some of the pattern that you've kind of outlined of this feedback loop of implementation plan and spec-driven development and feeding that into like a tighter context window. Will you also touch on sort of like validating and assessing the change? So one of the big challenges with like big version upgrades is things break in an unpredictable fashion. Maybe the whole navigation of the application structure changes. There's sort of these downstream second and third order effects that are hard to test for. And so sort of the testing starts to become a little bit of the bottleneck, especially these kind of like wide end-to-end tests. Um, just for example, we're currently jumping a React Native version. We're like several versions out of date. Lots of things have changed. Lots of package changes are required to kind of get that there. So a migration isn't a migration. It's like several migrations of that. And so the code generation piece of that has been relatively like straightforward, even with some of the spec-driven development. I think where some of the challenge has been is in validating that things work as they do, and wondering if you'll touch on any of that.
Yeah, absolutely. So I'll share a few things, right? One is a lot of validation still depends on how strong your test infrastructure is, right? So through the part of process of doing spec-driven development, it actually also generates a test plan. So using that test plan, you can kind of like execute, you can run all of those tests. Like, our system also, like if it is plugged into your CI, it actually will run all of those tests as well. Now, along with that, you can actually also ask the runbook systems to generate a manual testing plan. And I think those becomes like also useful just because, because of this learning system, you can actually provide some initial concepts of verification. So for instance, every spec itself, now you can have like a section for a testing, which is like, these are some of the things that needs to be verified before things can be valid, confirmed or verified. And some of the beauty of this is not everything has to be automated. Some of this can also include manual testing, like specific use cases. But a lot of this can still be AI generated and something which can get captured. So even if these things are not something which are comprehensive, imagine like, if you're capturing all of these things in every migration, in every step, you can actually continue reusing it and growing your corpus of testing. And again, this is again mix of both automated testing and manual testing.
Gotcha. Thank you.
Well, I think another thing to note is like the run book isn't just like starts from front to back. Like you get to stop at each of those, like you said, around manual testing, but you can start to very like surgically think about how do you want to do it. And this is where I think the human in the loop comes in because, just trying to say like, hey, AI, go do this for me, go build a plan and then go execute against it. Like, for the most, kind of simple of applications that might be fine. But if you're talking about a million line, Java application, like that's a huge issue. And so as you're thinking about building that runbook, you can start to now use your kind of, your developer senses to say, I need you to look here, I need you to look here, I need you to look here, I need you to look here. And then you can start to validate those along the way or leverage that to improve your current test suite. Because like it may help you identify the areas that you might be lacking in. But again, once you do that, you don't have to do it again. And so, kind of the, buy once, cry once kind of thing. And, I think that's one of the really big benefits of, kind of bringing this kind of formality to a process that is seemingly easy, but can get really complex to your point.
Right. And I think there is like, again, just reiterating some of the things that Chris is saying, like repeatability, having to kind of like, having a set of even manual test and corpus of like automated test that can be run, not just for one migration, but something which can be used in the future, right? And kind of like having this concept of verification as part of your playbook itself or runbook itself is very critical. Okay, so let's quickly go into the demo. Hopefully everything will work smoothly. We'll see. And so let me just kind of like give you an overview. I'll start with screen share. Okay, so obviously we have very limited time and some of these things can take very long. So what we're going to do is we're going to use a small repository. So this is like a repository I created called Task Manager. It is built in Python. And currently it actually uses what we call Pydantic framework, and it's on Pydantic v1, which is like one of the older frameworks. What we're going to try to do is we're going to try to upgrade that. So we'll kind of like, the reason I'm showing you this repository is one, it's, I think, open source, if I remember correctly. It is public, yes. So I'll share this also in the chat. So people may want to kind of like look around, skim through, they can do so. Where did the chat go? Okay, there you go. And second is kind of like, I'm just going to quickly walk through some of the concepts of Runbooks that we showed in the demo, how they kind of like relate with our actual product. And after that, we'll go into the actual execution. So you might be familiar with this kind of like a dashboard. These kind of things are becoming more popular ways of just getting started with the task. So a typical way of starting a migration or any kind of work is you kind of like provide some high level concepts here and start a new chat. Before we go into that, let's kind of like just go over quickly a few things. Here, this kind of like gives you a view of all the things that you're working on. And again, the most important thing about this framework is it's not something which is specific to you. It's something that you share with your team and your organization. So essentially, you're not even just looking at everything that you have. You can also kind of invite others and see who else are participating in this and be able to kind of like look at other people's work, be able to kind of like jump into somebody else's task and help out and provide feedback. The third thing I will share is the library. So this is the library that I also mentioned during the demo, during the slides. This is a system of templates that you can create and your entire organization can actually reuse them. So think about like this, when we are actually, doing a migration in a small code base, you can actually use that as a starting point for other people in your organization to be able to leverage that to create a migration for themselves. And this doesn't have to be limited to migrations. We definitely find migration is a very interesting and important use case, but you can also imagine like, creating a new Java service or, building a new front-end component. All of those things you can create templates for. And these are some things that people can use or like every developer can use to perform those specific actions. And we'll kind of like go through how these can be created. This is the context part. This is, I think, one of the most important part of this run. So every time something is executed, the agents essentially capture all of the learnings and create these micro learning systems that can then be used as context for future. Now, this is kind of like similar to if you use any kind of Claude code or codecs that they're like MD files, like markdown file, like claude.md or agents.md. But imagine these things can become really big, right? So what we do is essentially capture all of these things as micro learnings. And depending on the task at hand, we extract the context which could be useful, some of the previous learnings, and then apply that or share that with the agent. And the advantage with this is you essentially save a lot on the context window. Instead of having very giant markdown files which have to be constantly updated, this system automatically captures all of these things. And you can export them whenever you want, and then kind of like store them somewhere else if you need to. And last but not the least, quick overview of our settings. We will talk a little bit about like stack PR concept as well. But let's just go into the Claude code config. Given that we mentioned it actually uses Claude code, you can actually use your own custom API key. You can specify all the MCPs, as well as you can specify like the allow and deny list as well. So these kind of like things actually make it easier for you to customize and be able to use the configs or like the way you would actually use Claude code. Let's just go into the demo. I'm kind of like actually going to skip over sandboxes and personas, but like you can always find this information in our documents. So what we're going to do today is I'm going to ask let's migrate the Pydantic framework from V1 to V2. And our goal with kind of like prompts is really, there are three things that AI typically needs. One is a specification, one is a prompt, and one is a context. And all of those three, prompt should be the least useful information that you provide. It's definitely very directional, but think about this, right? In your organization, everyone would have different ways of expressing an answer or a question or a task. And we don't want multiple people working on different, like same task with different prompts getting different results. So that's why a framework like Runbook, although it relies on the prompts, vast majority of work actually is the context and the specs that are generated are used in this process. So I'm going to go with task manager and let's get started. So the first thing the system is going to do, it spins up a remote instance and it will actually set up the environment and check out your repository. So as you can see, it has already checked out a repository. Depending on the size of the repository, it might take some time. We also have what we call SSH sandboxes, where you can actually like run these sandboxes in your own environment, and then it will go and investigate that. Sorry, it will go and log into that and use everything from there. This also creates a great security layer on top of it. So the first part we actually did was a quick research. Given that this was a short code base, actually did research pretty quickly. Here it comes and asks you some questions. And I think these are also one of the most important parts. The further along you get into the process, the lesser review you have to do. So you start from kind of doing the research where you spend the most time doing the review. Then you go into the plan where you're also doing the review, but it's kind of like less than the research. And then the last is the code. And our goal is by the time the code is generated, the amount of review required is very little. So I'm going to go and like try to answer some of these questions. Okay, so should I update all patentic models through the code base to use? Yes, let's update all models. Okay, are there any specific patentic features you are currently using that you want to ensure work correctly in V2? Custom validators, ORM mode, config, classes, root,
All of them.
all of them. All right. Should I update the dependencies in the requirement file to specifically, or do you have version constraint I should follow? Please update the dependencies directly. Okay, do you want me to run existing tests after migration or verify nothing breaks or just perform the code migrations? Please also verify. Why would I not? Test and fix any test before finishing the task. So depending on number of questions, you can also like skip some of them. You don't have to answer everything. Sometimes you can also let the agents decide, but these are actually still very helpful pointers. And again, as you can see, the main thing we did here was we started with a very small prompt, and the user can actually specify a prompt in many different ways. And the goal here is like, you're just starting a task and let's work together before we actually have the agents go and implement this. So at this point, what's happening is we have checked out the code base in this sandbox. And as you can see, many of these messages that you're seeing are coming directly from Claude Code. If you have used Claude Code, this is actually a very similar experience, right? It's kind of like showing you some of the things that it actually is processing, reading, understanding all of this. And it may come and ask you more questions to kind of like clarify the details. In most cases, it will actually generate the runbook itself and help you, like ask you to verify it. So there you go. Again, small code base. So it only took 47 seconds. We intentionally chose a small one so we can actually do a live demo. At this point, it kind of like created the runbook for you. And this is like what we call actually the runbook. It has a few steps. It is broken down into 3 top level steps, which is update dependencies, migrate models, and update the test suite. Each of them itself will have like certain substeps. It may or may not have substeps. Like if a step is simple, it will probably just describe it as a top level step. And then it also has like some of these things. So as a testing part as well, right? Depending on kind of like, what you're trying to do, if you're doing a very large migration, you may also want to kind of like ask for some suggestions on manual test. This is also something we skipped over the persona. You can actually specify some of those details. Think of persona as system prompt. So you can provide more details in system prompts so that the agents may create runbooks in a specific way. So as Chris was saying before, this actually like helps you break down the task into smaller steps, and you can update the step one at a time. And that's also like one of the beauty of this is like, in this first case, it's actually only updating the requirements file, so it might not actually do a lot. But once you start doing the code changes, it will become more clear on how it is working and where we need to do course correct. So the next thing is as simple as kind of like saying, okay, you can execute the next step. If you feel like it's a small work, you can actually execute all steps together. But generally, we recommend you do one step at a time so that you can kind of like follow along on how things are going. So at this point, I'm going to just at least let's just do like entire step one, which is only going to update the requirements and see how it goes. We might not be able to get through the entire migration in time, just kind of like making sure we stay on schedule. But this is also one thing you can actually go and edit any of these steps. In fact, you can even do it while some of the things are going on because you can't edit something which is actually being run at the moment, but you can actually edit manually or even provide like some suggestions to the user, sorry, to the agent to go and modify these runbooks. And if you kind of like look into the details, these specs can be very detailed. And this is very intentional. The more details you get here, the lesser chances there will be that the final migrations generated will have errors. So looks like it actually did step 1.1 as well as 1.2. So it did commit these changes into this branch. If I want, I can actually like go and create a PR, or I can just like look at the diff. So let's just look at the diff, what happened. There isn't really like any rocket science here. So I'm gonna actually continue before we create a PR. And I do want to show kind of like, once we create a PR, what happens. But let's kind of like let it run a little bit of the cycle as well. Let me know if anyone has any questions meanwhile. It might take like a minute or two for this one to finish.
So one of the other things that I like about this is you can also use this to identify your gaps. And so, yes, it can help you validate what you're going through, but being that human in the loop part of, to the question somebody asked about, testing, like, all right, well, here's exactly the steps that are going to happen while going through testing. Is this going to be enough? Maybe, maybe not, but you're going to be able to clearly see what's in line and even where it's going to go and try to execute some of those things.
That's right. Actually, I am gonna continue some of more steps so that we get some more material to verify. That's right. Actually, like all of these steps helps you be able to kind of like, manually go and verify each of those things to make sure you can course correct. And many times we see kind of like, we were talking about one shots. We do have like one shot capability in this as well. You can actually like run it directly through Slack. But those things are like, nice and fun things to do. You can actually easily do that with any other things. You can kind of like, ask Cursor to do it. You can ask Cloud Code directly to do it in the terminal. But the beauty of kind of like, being able to do larger tasks is that it requires initial cognitive load to actually understand what's going on. But once you do this like a few times and you're kind of like in a place where the agent has good understanding of your code base, these things become really powerful. And that's because, similar to how when you hire a software engineer, it takes them some time to actually get up to speed. And you expect, there is going to be some investment there. But once you kind of like get there, everything else becomes a lot simpler. And that person actually like starts contributing very actively. So we think of this model as somewhat similar. You are picking off the shelf agentic systems and you're essentially creating memory layers for it. So it becomes smarter as you use it more.
Another really good use case that I've kind of seen here is just around bugs in general. Like if you get a bug or anything kind of submitted, you can have a run book that just goes and one tries to solve it, gives you a PR, and if it doesn't get a high enough kind of confidence score around like what it wants to or what it thinks it needs to do, it submits a report back, and you can have this really solid set of workflows. So you don't have to have your engineer go and try to diagnose what the problem might be, kind of run through the playbook that you would expect it to. It can do it for you, bring that information back to your engineers, lowering the amount of time they're spending on some of that kind of keep the lights on maintenance work, and allowing them to be able to leverage their expertise in the code base to be able to then quickly validate the PR, or be able to inject new context into it to be able to then hopefully resolve that problem a lot faster than you would in the past.
Right. I think a couple of other things also worth noting is with this kind of a model, you can also run your own sandbox. And the advantage of running your own sandbox is you can actually provide all the tools that you use. You can provide like, all your testing infrastructure, which means is now an agentic system, while running through a spec, also has a way to actually validate end to end. It can also like create previews. So you can go and verify the previews, like, even share a link with somebody in your team to kind of like go do the QA. And like these sandboxes will also have like these branches. So you can easily like, connect with the sandbox, make changes if you need to, and push more. So the idea there really is to kind of like, treat the system as almost like you're bringing another engineer in your team and provide everything that you would typically do to an engineer, right? You're providing it all the knowledge bases, you're providing it with all the kind of like tribal knowledge, you're giving review feedback, you're hand-holding them initially a little bit, with the expectation that like more you're doing it, the better the system gets. Okay, I am gonna actually dequeue this one so that let's have this be the last step, and then we can kind of like actually create the PR. Let's see how far it's gone.
I had a question while you DQ things. So is it checking in with PRs or stack PRs for like every step in the runbook right now?
Can you explain? Sorry, can you ask it again? I didn't
Like,
understand by checking in.
so when it completes a step,
Mhm.
is it committing essentially, or is this all running and it hasn't made the code changes quite yet?
No, it's definitely like, so
Oh,
all of the changes, so you can see 1.1, 1.2.
yeah. Okay, this is what I was looking for. Thank you.
So all of these things are getting committed. Now we do have a concept of stack PR. Sounds like you're at least like familiar with that. So with stack PRs, each of these things right now are separate commits. We have configuration through which, let me just open that in a separate tab here. So I can go in the config and I can say like right now I'm creating PRs in a manual mode, which means is it is merging all these changes to a single branch until I create a PR. Once I create a PR, it will base off of it and create a new branch and start committing there. You can also automate this entire process using a stack PR mode, where it automatically creates these stack PRs after every top level step, which is like, after if it would have done step 1.1 and 1.2, it will have created a PR, and the next PR automatically gets created as 2.1 and 2.2 on top of it. So that's why like, all these steps are run sequentially, and the
Right.
stacking can happen as one of the workflows. Right now we are
Right.
in the manual one, and you can also do a single PR where it's like, okay, we always only want to actually have a single PR. The thing is, many people are actually not familiar with stack PR concept. So we also want to make sure like people understand and kind of like, manually can control that workflow.
Right. Thank you.
Okay, looks like this one is also done. So what I'm going to do is let's just create a PR. And I'm actually like in this is our dummy account, so I'm not connected with my GitHub in this dummy account. But if you're connected with the GitHub account, like the PRs are actually created as you as authors. And I think there's like some nuances to it, but like it's important in some cases to actually have PRs created as authors so that you actually are incentivized to share with somebody else for review as well. Because right now I can actually go and review this thing and approve and merge it myself. But in this case, I'm not doing, if you actually connect your GitHub account, you'll actually have your user as the author, which means is like now you need somebody else to review it. Another thing to note here is like, I created a PR in the middle. Right now, it still has not modified the test. That means the tests have actually failed. Now, if I look back here, as soon as we created the PR and the test failed, it automatically detected that the CI has failed. And now it's going to look at like, okay, why the CI failed? Let's investigate and try to fix it. Now, this is also like one of the important parts of this workflow is the work is not done until the verification is done. Even if you create these PRs in the middle, it's important that, we are running all these verifications. The goal of the agent is not to just complete the task, but make sure it's accurate. And the same thing goes, we can actually also can look through the code and provide it with some comments as I would do for a regular PR. And then the agent will also pick those things up and actually address comments as well. So it's end-to-end workflow in that sense. It actually kind of like, handles all these, like the feedback, the human in the loop part. And that I think is like very important part of doing the entire migration. So we'll let it run a little bit, but I would say maybe we should try to kind of like wrap it up here. I think this is definitely like an interesting use case. I've already shared this repository with you. You can actually go look at it. You can also like provide feedback here and you can see how it works. Let me actually do that for one of them. There is v1 config style. Is there anything? Okay, I'm gonna just do a simple one. Let's just say put all package names in separate lines. So the only thing is like, we don't want it to be too aggressive. So you actually have to say aviator revise for it to pick it up. And that's pretty much it. So as soon as you kind of like post these comments, you can see there was like an emoji, which means like this has registered that there was a review feedback. Now, one of the things is right now it's actually running this operation of verifying the CI. So it's going to try to finish the CI verification before it starts picking up the review feedback. So just like queues it up, looks like it was able to address the CI. And now you can see like as soon as it finished the CI, now it's kind of like picking up the review feedback that you've provided, and it's going to work through that. So that's pretty much it. And it did add a comment here for kind of like, trying to fix the CI. And obviously, if the CI is still not fixed, it's going to continue working. We have like some configuration on controlling some of this behavior. But that was at least the basic workflow of how you would actually work with this. Last but not the least, one of the things you can do is you can go and publish this as a template. And what that means is once you publish this as a template, it's available in the library, and then other people can pick this up and go and use this same template either in a completely different repository or in a repository, same repository and a different code path to go and apply the same migration there. And maybe we can do that demo in a separate session, but like one of the things it actually does is it modifies the playbook to actually apply to the code base that you've shared with it. So if you kind of like provide a different repository or a different code path, it will actually review the steps and make sure that those steps apply for this code base. So you don't have to kind of like do a manual code mod. Here it actually kind of like adjusts automatically itself to the code base you provided it and also captures the new context based on the task itself. So I think that's pretty much it. Like I'm gonna just end this here with publishing the template that you can go and like share with others. Other people can just go and like use this plan, choose a different repository, and like provide some special instructions to kind of like modify the plan. I hope this was helpful. I know we are coming close to time, so let's wrap it up here. If anyone has any last minute questions, I'm happy to answer. Otherwise, we have, I'll also share my email and some of this. Here's my email. You can always kind of like shoot me a note if you have any questions, or if you want to try it out, you can always go to aviator.go and sign up. I hope this was helpful. Thank you so much. Thanks, Syed. Thanks everyone else for joining, and thank you, Chris, for joining me as well.
Of course. Yeah, it's always great to get the chance to join.
Okay, cool. All right, David, anything else? Should we wrap it up?
No, I think that'd be it. Thank you guys for joining. Really appreciate joining us and hope that was interesting.
Yeah.
Cool. Thank you,
Thanks,
everyone. Bye, Chris.